So, hello guys, my name is Max and welcome to this video today. We're going to continue to develop our Astro game using JavaScript and HTML. So, where we left off last time, we just got a bunch of asteroids drawn to the canvas and moving around. So let's continue from here. I'm going to start by going to the asteroid class here and make some small changes to it. So I think the rotation is a bit subtle, so I'll increase that one. And I think the speed is a bit too fast here, so let's decrease it. Yeah, let's actually remove the ×4 completely. Yeah, so now I think these look a bit more like they're moving in space and time and yeah, stuff like that, so I think this looks a bit better. Yeah, and we'll also use this scale value here later on in our code, so we'll save that to a size field here in the asteroid class. So we say this.size equal to the scale factor there. And yeah, so that should be it. So we go to the give state now, I guess, and let's create some new futures here. Yeah, so we can start by creating a function here that I will call generate level, like that, and that will just take the number of asteroids it will generate. So that's basically a higher level, the more asteroids will generate later. But for now, let's just set it to 3 during our testing here. And then basically you can just grab this code and drag it down here, since we use this as a skeleton for our new code. And just make sure here that we call the generate level function, like that. So instead of 10 here, we will use none, the value of how many asteroids we will generate there, and set that to the how many asteroids we actually generate them. And then instead of this stuff here, the max x and max y positions, we'll set that to some 2 fields here that we haven't created yet, but I think we'll call them something like canvas height and width here, like that. So let's actually create them. So we can say this.canvas width equals game.canvas context width, like that. And the same here for the height parameters. So we set that to game.canvas context of height, like that. So for now, shouldn't get any changes, but yeah, anyways. And I also think the Astro is a bit big here, so I will change that to 8, and I've actually saved that value to a variable here that we'll call asteroid size, asteroid size, like that. Set that 8, and instead of 8 here, we can set that to the asteroid size. Yeah, so that's good. So what to do from here? Well, we can create our ship class. So I just create a new file called JS ship.js, like so. And in here, let's just create our ship class that can extend the polygon in the same way as the asteroid did. And actually, it's quite similar to the asteroid, so you can actually use the content of the asteroid class as a skeleton here for our ship class as well. So just copy in everything from the asteroid inside of the ship. And the changes we're going to make, so we won't give it a random velocity, since we will use the keyboard to control that. And the same for rotation, we won't have a rotation angle, so just remove those 2 lines. The size isn't very important, so we can remove that as well. And let's remove the rotate function there. Yeah, so that should be it for the ship for now at least. So let's make sure that we include it in the HTML file. So source js ship.js, like that. And let's create a ship. So you can say this.ship equals new ship. And for the graphics, you can leave that. You can set a ship variable here for now, so you can set to the points ship, like that. And for the x and y position, the scale, set that to 2 for now, and then the x and y position, I guess, yeah, we can set that to the width of the canvas divided by 2, so we center it in both the y and the x values like that. And then of course we need to set the max x and max y values here, and that must be equal to the same fields here as the as asteroids are. So canvas height like that. So let's just see, or let's just make sure that we call the update and the draw functions on the ship. So we say this a ship update here on the update function, and then we can say this dot ship dot draw here to the with the context like that. But we haven't created the ship graphics, so let's do that. So we can just go here. Here it is. And yeah. So triangle have the centrum of mass or centrum of gravity in 1/3 from the bottom of the base of the triangle. So if you have a triangle, let's say that it's 9 squares high, then the center of mass should be 3 from the bottom here. So this should be a correctly drawn triangle like that. But this will be a bit strange in the rotation function that also in the coordinate system we have, since we have the rotation at 0 at start, and that is what do you say here. So we want just to rotate this rectangle 90 degrees to the clockwise here. And let's make it a bit more fancy with some heat shields or something like that, but we'll still use the same dimensions here. So this should be the basic shape I'm going to use at least. You can of course draw a complete arbitrary shape for the ship and use that if you want that. Anyway, so let's copy that in there. Hopefully now when we reload the page, yeah, you can see that the ship is drawn in the middle of the canvas. And 2 here as the size weren't actually that bad, so I'll keep that. Yeah, so let's make it possible for us to control the ship now, shall we? But for that we'll need our input handler, so I'll create a new file called input.js, and in here we just create our input handler like that. Tap class.extend like so, and then the constructor. It will take a list of keys this time, and inside of here we also have an object that we call keys like that, and we have a down object and a pressed object. So pretty similar to the one we had in the, which game was it? Yeah, the Space Invader game. Anyway, so we create a reference to the instance of the input handler, and then we add event listeners here to document. So we say document.add event listener like so on the key down event, with the event fallback like so, of course. And we have the key up event as well. But let's start with the key down. So here, actually we'll create this keys field first here. Sorry for that. So to create that, we'll just loop through all the keys in the key parameter here. So we say forward key in keys like that, and that's keys of course this object and not this one. Then we say var code equals to the keys key like that. So later when we put in this parameter here, that will be a JavaScript object, something like this, and then we can say left equals 37 and stuff like that, up equals 38 and so on and so forth. So left here will be the value that is stored in this one, and code here we can get from the keys variable using this syntax there. Anyways, then we'll basically say this dot keys, but on the code equal to the key like that, and then we say this dot down key equals false, The same here for the pressed object, like that. Yes. So yeah, actually we can use the code here for pressed since we aren't. Oh, sorry. Let's use the key. I'm a bit. Yeah. Anyways, let's use it like this. And we basically say here in the key down event, we say if self.keys event.key code. So if the current key code exists, then we just say this. Oh, sorry, self.down self.keys event.key code equals true, like that. And then in the key up method, you can basically just copy this and copy this line as well, and change this to false, of course, and this to pressed. So when we release a key, we set the values to false, and when we press down a key, we set the value through here, at least for the down object. Then we have two methods. Is down method. That's pretty simple. We just return this down key, like that. But for is pressed, it's a bit more complicated. Not that much though. That's the exact same thing that we used in the Space Invader game. So we just say if this pressed, key, return false. So if you already have pressed the key, then we don't want to register it again. Else, if this down. So if we haven't pressed the key, so if this is the first time to press the key, then we want to return this pressed key equals true, and else we just want to return false here. That means that no key is pressed at all. Yeah, so that's it for input handler. So let's just include it here in the source file, also in the HTML5. So we can say script source.js input.js, like that. And let's go to the mains file this time and just create it here after we have created a canvas. So we can say this.input equals new input handler, like so. And as I said, it took an object here with all the keys we want. So we'll have left and set that to 37, and up, let's set that to 38, right, 39. This is basically just the key codes, and then down 40, and let's set the spacebar as well, so spacebar, and that's equal to 32, like that. Anyway, let's just center all that. Whoopsie daisy. That wasn't my intention to do that. Anyway, let's try again. This is a new plugin, yeah. Anyway, like that. So for now, we have that declared, so let's load the page and see if we got any errors. No, it seemed to work. So let's go back to the game state and see if it works, but before we do that though, let's just make sure that we say self.input here as an augment to the handle inputs function. Yeah, so let's just create that one. So we can say handle inputs function with the input parameter, like that. Then we can say if input dot is down. Let's just test with the space bar for now. Let's just log out the test message to the console, so you can say test, like that. Let's just open up the console so we can see if it works. And now I'm pressing spacebar. Yeah, now I can see that the test message is written out. And when I press any other keys, even the arrow keys, nothing is logged out. So that's working. let's see if the isPressed functions works as well. So it's like that. Yeah, and now it only is written out when I press down the key the first time. So that's working. Brilliant. Yeah, so the rest from here is real simple. So we'll just copy this down a couple of times, and I changed it to this down instead, and just listen for the right, left, and up arrows instead. And when you press on the right key, this we want to do. We want to rotate the ship clockwise. So you say this is a chip that rotates, let's say 0.2 or something like that. Let's just test with that for now at least. And when we press on the left, we want to rotate counterclockwise, sorry. So we just say negative 0.02. Up now, yeah, you see that I can rotate the ship at least. But that was really slow, so let's, yeah, maybe too fast. Let's try with 6. Yeah, I think 6 is good here. Yeah, so that's good. So let's just create the acceleration function now, so we can actually move the ship. So for that, we will create a new method on the ship class. So you can say this ship dot move or something like that, or sorry, add velocity. Let's call it add velocity. Let's create that method right now. So add vel function like so. And here basically what we want, so we want to say we want to check if the current velocity is below a particular value. So for that we can use the Pythagoras theorem. So that's just basically the square root of yeah, two values. So say a times a plus b times b. That's equal to c, like that. Actually, c times c, we can use it like this instead. So we'll use this value, and where this is the maximum velocity that we want, c, and a and b here is the velocities in the x and y directions. So we can just say this dot velocity dot x times this dot velocity dot x plus y plus times this dot velocity dot y, like that. And then we just say check if that is smaller than the maximum velocity. So let's say 20. Then we want to add to the velocity. So we say this dot velocity dot x plus equals. Let's take a velocity here. So 0.3 maybe. Math of cosinus. And we haven't an angle yet, but anyway, let's fix that. And then the y velocity, let's add the sinus of an angle we haven't created yet. So yeah, so we need the angle in which direction the ship is facing. So let's just create it here. Let's set it to 0 at start, and just to see if it works before we change the angle, let's just yeah, let's do it like that. And see now if I press the forward key, yeah, the ship is moving. But isn't the decelerating, so let's fix that first as well. It's really simple, just say this dot velocity of x times equals 0.99 maybe, and the same for the y direction. So let's see now, yeah, so now when we go a bit faster here, and if I release the key, yeah, the ship is slowly slowing down. And yeah, let's make that go a bit faster, maybe even faster. Let's try 4. Let's try 5. Sorry for this, guys, I should have check this number before here. But anyways, yeah, I think that's good. Anyways, we don't want it to go to the right all the time. We want to be able to control the direction here. So for that, we can override the rotate method on the polygon class here a bit. So we say rotate like that, and that took a rotation angle, and I believe we call it theta or something like that. So use that in this one as well. And then we'll say this dot super with the angle, so we still rotate the ship. So let's see if it works. Yeah, we're still rotating at least. And then we just want to change the angle here. So we say this dot angle modulus equals. Oh, sorry, you can set it equals this dot angle plus theta modulus 2 times nat dot pi, like that. It's somewhat working, not really. Let's remove the model thingy. Yeah, anyway, now it works. So now I can control the space and we can move the ship. So that's cool. Yeah, but let's add some exhausting flames from the ship, shall we? Yeah, so that's really simple, quite fun to do as well. So let's go back to the polygon drop program, and let's draw some exhaustion flames. And I'll use this particular shape, I think. So yeah, basically just copy it, and yeah, let's close down that program for now. We won't need it. Let's go back to the game class, and let's call it flames. Why not? Like that. And let's put that as the second parameter here to the ship class. So we say points flames, like that. And let's just call it pf polygon flames now. Then we say this dot flames equals new polygon with the pf as arguments there. Then of course we want to scale it with the s value, like that. And then just make sure that you draw it. So context.draw polygon, this dot flames, this dot x, this dot y, and then we rotate as well. Lucky that we overrided this one. Anyway, here we're going to say this dot flames dot rotate with the angle, like that. So for now, you should see the exhaustion frames drawn from the ship, and they are rotating with the ship as well. So that's good, cool. But anyway, we don't want to draw them all the time, only when the down key is pressed. So for that, we will make a new field here that we call draw flames, and we set that to false at start here, like that. And then we can say if this dot draw flames, then we want to pull that one, so we draw them. And in the game state, we just want to make sure that we say this dot ship dot draw flames. Let's set that false here before we check if the up key is pressed. And if it is, then we want to say this dot. Actually, we can do that inside of the add velocity class here. Yeah. So let's do that. So we can say here we can say this dot draw flames equals true. Yeah. So now they're only drawn when I press a key. So that's cool. Awesome. Yeah, so let's do some shooting now, shall we? That's pretty simple, actually. But for that, I think we will, yeah. Anyway, we'll do one thing at a time here. Let's start by creating a bullet class here. So we can create a new file called bullet.js and set them the JS folder as well. And just make sure that we include it here. So script source js bullet.js, like that. And inside here, let's create a bullet class, and that should extend the the normal superclass there. Anyway, and inside of here, the constructor that will take x and y position and an angle. Now we say this x equals x, this y equals y. Should put this. Now we say this dot velocity equals, and the x velocity. Let's set the speed of the bullets to 5. Method cosinus of that angle, of course, and the y velocity 5 times method sinus of that angle, like that. And the update method, it's the simplest in the world. It just say is the x plus equals is the velocity of x. The same for the y direction, or the y position, sorry. And then the draw method, that take context as a parameter, of course, and let's draw it as a stroke. But for that we'll need 2 coordinates, so let's just say the previous and the x and y positions here before we change them in the update method. So you say this dot previous dot y equals this dot y, like so. And then we can say context dot begin path, context dot stroke, context dot move to this dot previous x, this dot previous dot y, prep y like so, and then we just draw a line, so line to this x and this dot y. So that's it for the bullet class. Real simple stuff. And let's create it here in the ship. Yeah, let's create a new method on the ship that we call shoot, and that will basically return a new bullet. Actually, we will need to set some fields on the bullet first, so we will set while b equals new bullet, like that. And here we will say boom boom boom, this dot x, this dot y, and this dot angle for the positions. But let's actually not use the center of the ship here. Let's use the front of it. But for that I think we will need to redraw the sprite. Let's check here. Yeah, it should start on 6.6, or we want it to draw from the first point of the ship, or the front of the ship. So yeah, let's just go back to the polygon draw class here, and let's redraw the ship one more time. I think it's sort of that. Let's try again. I think we draw it something like this. Yeah. Anyways, so you can see that now the first point is this 6 here. So we want the bullets to be drawn here from here, or be created from the front of the tip of the ship. Anyway, that should be the last thing. Last time we changed the ship sprite. Yeah. And of course in the ship class we changed the shoot method here to we can say this dot points 0 plus this dot x, like that. And the points here, of course, are a member of the original polygon class. If you remember, you can take a look here. This is basically this field here that the ship has as well, since it's extending the polygon class. Anyway, so you say this dot points 0 plus this dot x, and the same here with the y here. So that should be drawn from the tip of the ship now, or be created from the tip of the ship. And then we can say b dot max x equals this dot max x, and b dot max y equals this dot max y as well. And of course we haven't created those two fields yet, so let's just do that. So we say max x null, max y, set that null as well. And then here when we do the updating, basically what we want to check is, we want to check here, we will say if 0 is bigger than this x, or this x is bigger than this max x, or 0 is bigger than this y, or this y is bigger than this max y, like that. Then we also want to say this dot shall remove equals true, like that. And let's just set that field to false here at the start, like that. So yeah, now let's see if the bullets are working. So let's go back to the game state. In the generate level function, let's just create our bullet object as a new list, like so, sort of that, like so. And then here in the handle inputs method, basically want to check if we would say if input dot is pressed spacebar, then we want to say this dot bullets dot push this dot ship dot shoot, like that. So I should create a new the new bullets for us. Then we just loop draw bullets, so we say bar for bar I equals 0, len equals this dot bullets dot length, I is less than len, I dot plus, this dot bullets at I dot update, like that. And actually let's make a reference here and call that b. So we say bar b equals, like that. Since here we want to check if b dot shall remove, then all we want to do is basically we want to say this dot bullets dot splice at I, and want to remove one object. Then we just make sure that we decrease the length and the I variable there. Anyway, let's just copy this down in the render method as well, and let's get rid of some stuff here. Let's call it draw in the context, like that, and hopefully now we should be able to shoot. Yeah, and that seems to be the case. So you can see that the bullets are created from the front of the ship. So that's good. That means that it at least works. So that's good. Yeah. So let's just make one final thing before we end this video. And like when we hit an asteroid, we want it to be split. We want it to split if it's above a certain size. So yeah, so let's do that. So for that, if you remember, I had this Google Drive document in the first video. I can see if I can open it. Like here, I guess, with the basic, and a link to this is in the description, guys, if you want to look at it. Anyways, and we have this contains point method that took some arguments and stuff, and that could basically say if we hover over a polygon whether or not a particular point was inside of the polygon. So we use that method for our splitting here to check if a bullet is inside of an asteroid, then we want to split it, something like that. So you can just copy that code. I think you should be able to do that with the restrictions I have given you. So just go back to the code here. Let's go to the polygon class, and as you can see, we have the empty skeleton here for the function. So just get rid of some of the parameters like that. Let's get rid of that one as well. Let's tab it in. Yeah, so that's looking fantastic so far. but we haven't the p object, so we just say well, p equals this dot points, of course, since that's what we want to check against. And let's make this a bit more easy to read here. So, and this is completely optional. Don't have to do this, but yeah. Anyway, I think that's look a bit more clear what we actually are doing here, even though I'm not too confident in what this algorithm actually are doing, but it works, so that's fine. We'll use it anyway. So that's good. So we have that done at least. Yeah. So let's go to the Asteroid class and override this method a bit. So that will make a bit more useful for us, at least in this game. So we say as point. So we override it. And as arguments, it will take an x and y position. And it's really simple. Just return. Don't forget the return here. that's quite important. The super function. And then we just say this.x, this.y for the offset, and x and y like so. So ox and oy here, the offset, that will be equal to the position of the asteroid, and x and y position here are the arguments from the method call here. And that will of course be equal to our bullets later when we implement it. Yeah, so we can close down this for now. Hopefully if we load the page we won't get any errors. No, it seems to be working still at least. So we just go to the game state, and basically all we need to do, this is a bit stupid way of doing it, but anyway, we could use some like quadratic trees and stuff like that, but we won't bother with that. We'll just loop through all the bullets and check if it hits the asteroid. So for that, let's just make a reference here to the asteroid we're at, and let's just call a.update instead. Then we just loop through all the asteroids. So you say for.j equals 0, length 2 equals this bullets, dot length, like that. J equals less than length 2, j plus plus, like that. And I just realized that I have spelled this bullets all over the place, but let's change that to bullets instead. Okay. Bad idea. Let's check again. Asteroids is not defined. Line 66. Sorry. Here of course was still have this. Yeah. Okay, still working. Let's change the bullets now. Yeah, it seems working. I see, so we don't override something stupid. Nope, we override that, and that. Okay. Anyway, so we just take out the current bullet to say this dot bullets at j, of course, like that. Then we can just say if a has point b.x, b.y, like that. Let's just splice the bullet now. So we say this dot bullets dot splice j, not I, and then we decrease the j and length 2 variables. So let's see now if we should hit the asteroid yet. You can see that the bullets are disappearing. So that's working. We got some errors here, so one moment guys, and we'll see what that is. Yeah, so I basically found out the error. It shouldn't of course be I here, it should of course be 1. Nothing else. So for now it is working as it's supposed to do. Yeah. So left to do is basically just to split the asteroids, and then let's call it a day. So the splitting, let's do the obvious and stupid way again. Like, why not? Here we can say, we will just say if a.size, remember the size we put in the asteroid class here, or the scale factor. And you can just say if a.size is bigger than the asteroid size divided by 4. So, yeah, see, so if it had been, so basically when we split them, we will divide the size by 2. So if it had been split 2 times, then it will disappear, basically. That's the plan at least. Anyway, then we'll say for bar k equals 0. It isn't often you need to go all the way up to k, but anyway, that probably means this is a bad algorithm. Anyway, k is less than 2, k plus plus, and we can just copy some code here from the generate level method. Basically all of this stuff. Just copy it in. Type it in a couple of times. Well, we haven't set the position anyway. We'll do that. And then we'll say a.size divided by 2, like that. And for the position, x position, we set that to a.x, and the y position to a.y, like that. Then we basically want to increase the length and the I here. Oh, sorry, the length. We want to increase that. Else, you can say else here. We want to subtract from the length. Then we just want to splice from the asteroid object. So we say this dot asteroids dot splice. That's I this time, and we want to splice one object, and then we want to subtract from the I again. So that's why we don't add 2 to the length there or something like that. We will just, actually we can do that. That maybe makes it a bit clearer what this thing actually does. So let's just put out the length there, get rid of the else statement. Yeah. You can see it works at least. So for now, when we hit the asteroid, you can see that it should split. Yeah. And if it again, it should split again, and one more time, and it should disappear. So that's working. So that's good. Yeah. So that's almost it. Just one final thing. I don't think the asteroid should start on 100, 100 each time. So let's make it a bit more random where they start, or at least on the edge of the canvas. I think that's cool. So let's go back to the generate level method, and before we create the asteroid, let's just set the x and y field here. That will set to 0, both them. Then we can say if math or random is bigger than 0.5, then we want to set the x position randomly. So we can say x equals math of random times this dot canvas width. Then we say else y equals math of random times this dot canvas height, of course. And then do is basically set the x and y positions here, like that. Until now, yeah, you can see that they start on the edge of the canvas. So that's good. So, yeah. Let's just make one final stuff here to code. Let's make the level progression system, and then we will probably make a third short video of this, or maybe not that short, where we add menu states and stuff like that in a third video, and of course when we hit the game over state and stuff like that. But anyway, let's do the level progression in this video as well. I think we can fit that in. Let's see how long we are recording. So yeah, so 45 minutes. Anyway, let's do that. It won't take long. Anyway, so remember this num variable we set here in the generate level function. Basically, we want this to be depending on the level we're at. So let's just make a level field here. So you say this dot level. Set that to 0 at the start. Since we are programmers, we don't want to setting stuff at 1 at the start. We set things to 0, since we are cool. Yeah. Anyway, now we basically want a function that is have this as the argument, the level, and we want that to be decide how many asteroids we want. So I have this program here that's built into, I think, all Macs that are made. Let's zoom out a bit. Zoom in, yeah. I think this is something good here. So let's say we have on the x-axis here we have the level, on the y-axis we have the number of asteroids we want. So we want something like, we want to round it, of course. And let's test some different types of function. So let's create, let's test, let's say x for now. Let's do something like this. So you can say, when the level is 1, we will get 1 asteroid. When the level is 2, we got 2 asteroids, and so on and so forth. But that's a bit boring here. But let's try x to the power of 2. We will get a much more interesting curve here. Something like that, some sort of growth, exponential growth. But yeah, I think that's a bit stupid to have it like that. So let's have that steep of progression. So to ease it a bit, we can can sort of divide the x value before we take the power of 2 there. And yeah, now we can see that we have this type sort of curve going. But we want it to not have 0 at start, so we can add, let's say, 3. So we'll have 3 asteroids at start, but that's a bit, maybe too many levels. So 20 maybe was a bit too big here. Let's try 15. Yeah, that's probably good. But let's add 5 to the x position as well. Yeah. So this is a bit good here. So you can see when we are on, maybe this is 2. Let's try it like that. No, 10. Yeah. Anyway, so we'll have 3 asteroids when we're on level 0, 1 and 2. And then level 3, we will have 4 asteroids, and so on and so forth. On level 10, we'll have 5. 15, we will have 7. And it will grow quadratic here. So on level 30, we'll have 15 asteroids and stuff like that. So we use this sort of curve for our asteroids, I think. Or you can, of course, modify this to fit however you see good, or what you think is a good algorithm. Anyway, so let's create that function. So we have map around, and then we had, what do we have? The level, this level. And then we add like 5 to it, I think. Then we just divide up by, what do we divide with 10. And of course, this shouldn't be like that. Yeah, it should be like 2, I guess. And then we just add 3. So let's see if it works. So on our page we should see 3 asteroids. Oh, sorry, we added 5 to the thing there, of course. So let's just add 2 instead. Yeah. So we now have a level progression thing going. So if we increase the level to 30, we should have like 15 of them, or something like that. So yeah, so that's working. So we have more asteroids as we are going higher in levels. So that's good. But let's head back to 0, and basically what we want to do is we want to, after we have done all the updating, all we want to check is we want to say if this asteroids length is equals to 0, then we want to call the generate level method again and increase the level we're at. So level plus plus, and then we want to generate level. And let's set the ship's position back again. So we say this dot ship dot x equals this dot canvas width divided by 2, and the same for the y position here, but with the height of the canvas, of course. And then we can actually get rid of this here, since we are setting the positions here, so we don't get that long line there. Anyway, yeah, so now let's just set it back to, where are you? Yeah, let's add nothing here. So now when I hit, so there are no asteroids left, bear with me guys, we should get a new level going, and we should get some more asteroids drawn for us. So let's see if that works. Ooh. Ah, come on, one left. For God's sake. Ah, come on. Come on, come on, come on, come on. No, so close, so close. Maybe this game is a bit stupid to play. Anyway, yeah, you can see that the level resetted and stuff like that. So in the next video, we will do the score system, and we will display which level we're at and stuff like that. So I hope I see you then. So that was everything for today, guys. So thank you for watching, and I hope I see you in the next video. Bye!